Hello, this is Mrs. Taylor, and I am going to discuss continuity algebraically or analytically. It really means the same thing. So just a refresher on the definition of continuity, there are three conditions. In order for a function to be continuous at a point, a c-value, the three things that have to be true are f of c is defined, limit as x approaches c if f of x exists, and that limit equals that defined value. So what we have done is we've identified points of discontinuity on a graph, and now we're going to look at just the function. Without having access to a graphing calculator, you need to know how to determine the continuity of a function. And so the thing to remember is certain functions are understood to be continuous everywhere, and we do not need to prove their continuity. So for example, if they asked us to discuss the continuity of sine of x, it is understood that sine of x is continuous everywhere. So we don't really need to provide any proof of that. It's just understood to be true. It'd be a really straightforward answer. A case where a function is not understood to be continuous everywhere is a rational function. So let's say we had g of x equals x squared minus 1 over x minus 1. And even though separately the numerator, which is a polynomial, and polynomials are understood to be continuous everywhere, and the denominator is also a polynomial, even though the numerator and denominator are polynomials, as a function together, it's not necessarily continuous everywhere because the denominator could equal 0, which creates an undefined point. And the question is, if they ask us to discuss the continuity, what do we do? How do we approach that? How do we provide an answer with such a vague set of instructions? And so I created a Prezi to introduce you to discussing continuity algebraically. And so let's see. First thing you need to do is think about the domain. Domain is the x values for a function where the function is defined. And so looking at g of x, we see at x equals 1, g of x would be undefined. So this would be where g of x would be discontinuous. So a function isn't discontinuous over an interval, it's discontinuous at a point. And so from there, after we realize that, the next thing we do is determine the type of discontinuity. So we want to know if it's removable or non-removable. And when we factor the numerator, the x minus 1 factors cancel from top and bottom. So this makes the discontinuity removable. And so from there, you present your conclusion. You would state that the function g of x has a removable discontinuity at x equals 1. You could also present the intervals of continuity by saying the function g of x is continuous on the intervals negative infinity to 1 and 1 to infinity. And for those intervals, you would use parentheses because they would be open intervals. You don't want to include the value 1 in those intervals because that's where it's discontinuous, and you never use a bracket closed interval with infinity. So, in conclusion, if you're asked to discuss continuity, what you want to do is first determine the x values that make the function undefined, then determine if anything can be factored out, and then if you can factor things out, then if they cancel, they'll be removable discontinuity. If they don't cancel, they would be non-removable. And we know that that also determines if it's a point discontinuity, if it's removable, or a vertical asymptote if it's non-removable. So what happens when the function gets a little more involved, such as a piecewise function? So in this case, each piece is a polynomial. So I know that each piece is continuous on its given domain because it's a polynomial. And I don't have to prove that. It's understood to be true. So the question is, all right, if the two pieces are continuous, what about the x value where they meet at x equals 0? And with piecewise functions, this is where those three requirements become so important. You confirm that these three items are true, then you've proven that the function is continuous. So first we have to prove that f of c is defined, in this case h of c. So h of the value in question, which is 0, h of 0, is it defined? Well, here x could equal 0, and when I plug it in, I do get a value. So I would first state that h of 0 equals 1. All right, and then the next question is, does the limit exist? And so with proving that a limit exists with a piecewise function, you have to prove that the limit from the left is equal to the limit from the right, because that is the conditions for a limit to exist. So when x is less than 0, that's approaching from the left. When x is greater than 0, that's approaching from the right. So my limits from left and right would look like this. The limit of h of x as x approaches 0 from the left would be equal to the limit as x approaches 0 of x plus 1, because that's the function that defines the left side of the curve that's approaching x equals 0. And then the limit of h of x as x approaches 0 from the right would be defined by the function x squared plus 1. And so when I evaluate these functions, both of them are equal to 1. And so since the left-hand and right-hand limits are equivalent, the limit does exist, and it equals 1. So we've shown that h of c, which is 0 in this case, h of 0 equals 1. It exists. It's defined. We've also shown that the limit exists, also that it equals 1. So indirectly, we've also shown the last condition, which is the fact that h of c must equal the limit as x approaches c. And so I need to state that as well. And so because I have shown that where the two pieces meet are equivalent, that I have shown using the conditions of continuity, then I have shown algebraically that this function is continuous on its entire domain. It's everywhere continuous. So I would just state h of x is everywhere continuous. And if it asks me to explain or support my answer, that's what all of this limit notation is. When you're being graded on these assignments, you will be graded by someone who understands the conditions for continuity and why you must show each of these items. And so you don't really have to explain every step, you just have to complete every step in order to fully support your answer. And so that's how you would discuss continuity using your algebraic or analytical skills as opposed to graphical skills.